Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find area of the Pentagon? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. This is Pentagon ABC segment DE, and our goal is its total area. Reading the figure, the short top side AE is 11, and the right side CD is 22. Those two numbers, together with the tick marks, are everything we will need. The three matching strikes say segment AB, segment BC, and segment DE are equal. Call that common length X. The label appears on those exact rails now. Notice the three square corners. The angles at A, at B, and at C are each 90 degrees. So side AB, side BC, and side CD turn like a neat staircase, each a right angle from the last. Here is the key idea. Sides, segment AB and segment BC are equal and meet at a right angle, so they are two sides of a square. If we supply the missing corner, the awkward pentagon becomes a clean square with one corner sliced off. Aha! Add the missing corner F and draw segment FA and segment FC. Corner F turns ABC segment DE into square ABCF minus triangle FDE. The original green pentagon is now one clean subtraction. On the completed top side, FA, the source gives segment AE equal to 11. Therefore, segment FE is x minus 11. On the completed right side, FC, the source gives segment CD equal to 22. Therefore, segment FD is x minus 22. The removed corner is right triangle FDE, with perpendicular legs segment FD and segment F. The third equality strike is on segment DE, so the hypotenuse of this corner triangle is the same x as the square side. Aha! The same x controls square ABCF and hypotenuse segment DE, while the two missing corner legs are x minus 22 and x minus 11. Pythagoras now gives one equation in one unknown without exposing the admissible root yet. Let us expand carefully, one square at a time. X minus 22 squared is x squared minus 44x plus 484. Now the other one, x minus 11 squared, is x squared minus 22x plus 121. Next, we will add these two expansions together. Add them term by term. The 2x squared make 2x squared, the x terms combine to minus 66x, and the constants 484 and 121 make 605. So the left side is 2x squared minus 66x plus 605. Remember, the whole thing equals the hypotenuse squared x squared. So 2x squared minus 66x plus 605 equals x squared. Now we tidy this into a standard quadratic. Subtract x squared from both sides. One of the two x squared cancels, leaving x squared minus 66x plus 605 equals 0. A clean quadratic we can factor. We need two numbers that multiply to 605 and add to 66. 11 and 55 do exactly that, since 11 times 55 is 605. So it factors as x minus 11 times x minus 55 equals 0. A product is 0 only when a factor is 0, so x equals 11 or x equals 55. We now have two candidates and must decide which one the figure actually allows. The side CD is 22 and must fit inside the square side x, so x equals 11 is impossible. The valid side is 55. Now the arithmetic of areas. The full square ABCX1 has side 55, so its area is 55 squared, which is 3,025 square units. Put x equals 55 back into the legs of the corner triangle. x1 to D is 55 minus 22, which is 33, and x1 to E is 55 minus 11, which is 44. Since the corner triangle is right-angled, its area is 1/2 the product of the two legs. 1/2 times 30, 3 times 44 is 726. The Pentagon is precisely the square with that corner triangle removed, so its area is 3,025 minus 726. So the green Pentagon IBC segment DE has area 2,299 square units. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.